In section 7.2, I want you to be able to find the inverse of a function by graphing. So we want to go over a few vocabulary words before we get started. We're going to talk about a relation, which is a set of ordered pairs. So you could have like 1, 2, kind of like the points that you graph on the coordinate plane. Order is important. If you would graph 1, 2 and you would flip-flop these points, 2, 1 would not be the same point. That's why it's called ordered pairs. A function is a relation, so that means it's a set of ordered pairs in which every input, that would be your x, is paired with exactly one output, which is your y. Now, before we get into inverses, I want to refer you back to what we've already done with numbers. We've worked with additive and multiplicative inverses. So the additive inverse of negative 2/3 is positive 2/3. We add them together and we get 0. But the multiplicative inverse is when we take the numbers and just take the reciprocal. So this would be negative 3/2. So keep inverse, this multiplicative inverse, in mind as we're going along to finding the inverse of a relation. Okay, so in the first example, we are going to find the inverse of a relation. And all you have to do, here we just flip-flop the numerator and the denominator. If we have a table, or a set of ordered pairs, we're going to switch the x and the y values of each ordered pair. Now here it says complete the table to find the ordered pairs of the inverse, graph the relation and its inverse, and identify the domain and the range of each relation. Okay, so here is our relation. We have a set of ordered pairs here, so we're going to graph 0, 6, so go ahead and graph that, 0, 6, and then 2, 10. And then we have 5, 12. So here's 5, 12. And then we have 8, 13. And then we also have 10, 13. Okay, now we're going to connect the points in the order that we graph them. So we'll go from here, and then here, here, and then finally here. Okay, now this is a line that we're always going to include when we're graphing a relation and its inverse. This is the line y equals x. So you can think of it a couple of different ways. The intercept would be at 0, so we would be right here, and we would have a slope of 1, so up 1 over 1, up 1 over 1. Or you could think of it as whatever x is, that's what y is, or vice versa. So if we have x is 1, y is 1, x is 2, y is 2, and so on. So we have 2, 2, 4, 4, and so on. Okay, now we're going to find the inverse. Very easy to do, so don't make it any harder than it needs to be. We're just going to flip-flop the x and the y. So all of my x's are now going to become y's. So this is going to be 0, 2, 5, 8, and 10. All of the y's are now going to become x's. So that's going to be 6, 10, 12, 13, and 13. Okay, so now let's graph those ordered pairs and see what happens. So the first one is going to be at 6, 0. And then we have 10, 2. We also have 12, 5. And then we have 13, 8. And we also have 13, 10. Okay, so now let's connect those points. And this is going to be our line of reflection. So if you can you probably can't tell real well if I fold this, but if I would fold this paper right on that line of reflection, this point would go on top of that one, this would go on this one I would flip over to here, that one there, and this one here. So now we're going to talk about the domain and the range of the relation. Now remember, domain is x, range is y. So if we put domain and range in alphabetical order, x and y in alphabetical order, that's how they match up. So we're going to look at the relation, which was this one right here. We want to figure out what values x are, or we have for x. So this one goes from when x is 0 and all the way to the end here, x is 10. So we're going to say that set of all numbers x such that x is less than or equal to 10 and greater than or equal to 0. So that defines the domain. And now we're going to look at the range, so that's on the y. So the lowest one I have right here is 6, and the highest I have is 13. So we're going to say set of all numbers y such that y is less than or equal to 13, but greater than or equal to 6. Okay, since we flip-flopped our x and y, we're also going to flip-flop our domain and our range. So the range of the relation becomes the domain of the inverse. So we can just copy this over here and make it an x, set of all numbers x such that x is less than or equal to 13, because this is going up here, just switch it to an x, greater than or equal to 6. And here with our range, we're going to bring the y over here and we'll change this. So it's going to be set of all numbers y such that y is less than or equal to 10, but greater than or equal to 0. Okay, you have a couple problems to try for the You Try It. So make sure you get that done before you do your worksheet.